All right, this is the Chapter 5 practice test. Before I start this, just real quick, what your formula sheet will look like. I'm honestly not sure if I'll put this on a formula sheet or if I'll be able to fit this on your test somewhere. But either way, whatever it looks like, this is what you'll get. You'll have the sum of differences of cubes, the formulas for those, and then you'll get this table over here that has all the normal numbers here, all the perfect squares in this column, and all the perfect cubes are in this column. A couple people have asked, how do we know when it's a difference in squares compared to a difference in cubes? The biggest thing is double check whether the numbers are perfect squares or perfect cubes, which means double check this column. To that, we'll look at some of those in long. But let's go ahead and look at this practice test. I gave myself a lot of room, so if you're wondering why mine is 4 pages and yours is only 2, that is why. So we're starting with these factoring problems. Actually, but this one has a leading coefficient, so let's start with my x. Remember, your first number times your last number goes in your x. 6 times -2, which is -12. Middle number, so I'm looking for factors that add up to be -1. So my factors of -12, I have 1 and 12, but remember that's going to be positive, so I need one of those numbers to be negative. If both of them are negative, it still would multiply to be positive 12. So I'm going to just, I always make my left-hand side negative. So -6 and -3/4. So which one of those will be -12? Which ones add up to be -1? Well, we're really close. 4 add up to be +1, not -1. If that happens, you have the right number but the wrong sign, all you have to do is switch it. Now it adds up to be -1 like we want, and it still multiplies to be -12. Now this is where I tell you guys, fill out x and double check this, because this is where a lot of students miss it. If for no other reason, check your signs. 3 times -4 is -12. 3 plus -4 is -12. So double check that. It takes 2 seconds to calculator, and it'll help you guys out. So then we go on to we have x plus 3 times x minus. Then this is where they missed it. So that's what they left. They circled it and they thought that was their answer. You're close, but remember, if there's a leading coefficient, you have to divide these numbers by that leading coefficient. The other thing a lot of people missed is once they divided, they just left it like that, or they put the 6, so 6x plus 3 and 6x minus 4. Again, you're close, but you have to reduce first. So here, that 3 over 6 is 1 over 3. Divide both of them by 3. 6, if you divide by 2, is 2 over 3. No, sorry, I made a mistake. 3 over 6 is 1 over 2 if you divide both by 3. I said the right thing. I wrote down the wrong thing. 3 over 6 is, if you divide both by 3, is 1. Once you have this, then now is where you put those denominators up front. So we have 2x plus 1, x minus 2. Now, obviously, your work you can distribute times 3x, 2x times -2, 1 times 3x, 1 times -2. You could do that. That's a great way to check your work. I highly recommend it. However, I'm also a realist, and I know a lot of you guys are not going to take your time. So one way you can at least small check is take 2x times 3x and make sure that is your first term. Somewhere, you look like this up here, this step, that'd be x times x is x squared, so you know that's wrong. So you take those first 2 terms, multiply them together, and that better give you your first term. Okay, so the next one. Now, right away, there are 4 terms here, so I know it's probably factor by grouping. So we group these together, put the plus. Again, you don't actually need that plus sign, so if you want to ignore it, that's fine. From the first group, I'm going to take out an x squared. That's going to leave me x plus 5. The second group, I'm going to take out a positive 3. That's going to leave me x plus 5. the parentheses, they go together inside one set of parentheses. The other set of parentheses are the ones that are exactly the same. So x plus 5 and x plus 5 go together in one spot, x plus 5. Now, technically, you could do the same thing with this one that I just, if you want to double check, you can take your numbers, x squared times x, should be x to the third, that should be your first term. You're right, I'm just saying if it's wrong, you're definitely wrong. So it's a good thing to double check real quick. Right path. Number 3, when you look at this, so the 3 things we're thinking about, is it a difference in squares? Well, again, if you look at your perfect square here, there's not 10 on there anywhere, and there's not 12 on there, so it's not perfect squares. What about a sum or difference of cubes? Because that's another one of the terms. Here, so it's not a difference of squares. It's not a thing you have to check before you think it's is double check to see if there's a greatest common factor. Between 10 and 12, there's a greatest common factor. X squared x to the third, we can take out x squared. 10 divided by 2 is 5. I had x squared, I took it out, so we'll have it left. 12 divided by 2 is 6. I have 3 x's, I took it out, so I have 1. Number 4, again, there's 2 terms, so the first thing I would check is difference of squares. So double check in my squared column. Yeah, 4 is here, 12 is here, so they're both perfect squares, and it's subtraction. So this is a difference of squares. So I'm going to find my A and B. So what number squared is 4? Go back here. If your 4 is here, it is 2. One you guys know. Same thing with the 25, but so 25, that is 5 squared. Means by B is 5. So from here, you use your formula. So I have A plus B and A minus B. Now, now again, I'm giving you a hint right here. I'm saying factor completely. So that means you're probably going to take out a greatest common factor, and then you're going to factor whatever's left. Or you're going to factor it using some method, and when you're done, you're going to factor something else out. But factor completely means you're going to factor twice, at least. And for our purposes, it's almost always the greatest common factor. That's how you're going to start. So I can take out a 3, x squared, 27 divided by 3 is 9. Can't do anything with the x. 60 divided by 3 is 20. Factor completely part means we're not done yet. Now I have to factor this part. So factors of 20, that has to be 9. Factors of 20, it is 20. X plus 5. We don't have to divide the 4 and the 5 by anything because there's no way you can forget. Don't forget this 3. You factor that 3 out, so you still. But again, factor completely. Tip off. That means you're going to be factoring more than once. So the next one, we have 3 terms. Most of the time we have 3 terms. It's going to be the trinomial factoring like we've been doing. You can check, not a bad idea to check for greatest common factor first, but for the most part, this is how we're going to do these. Now remember, the top number is your first times your last. So it's 1 times negative 15, negative 2. So factors of negative 15 that add up to be negative 2. Again, negative 15, I always put the negative with the left-hand side, negative 1 and 15. Negative 3 and 5. 4 doesn't work, and we're back to 5, so we can stop. So again, same thing as before. These 2 add up to be positive 2. So change both of our signs. Change that to a plus, change that to a minus. Now they do add up to be negative 2. So positive 3, negative 5. And again, this is a great place to check your work. 3 times negative 5 is negative 15. 3 plus negative 5 is negative 2. With x plus 3 and x minus 5. Similar to number 5, technically we would divide these by 1, the number in front, but really you don't. When you divide them by 1, it doesn't change anything. So this there is no number in front, you can stop here, but only if there's no number in front. That's what a lot of people did wrong with number one, is they, like I said, when I did that one, they forgot to divide those two numbers by 6. They got too used to doing it a shortcut where they don't have to divide by anything. We have another trinomial. Times 18 goes here. Factors of 18, I have 1 and 18, 2 and 9, 3 and 6, 4 and 11, 9. These are all positive, so it's a little bit easier, but it's always I'll check. Positive 2 positive 9 is positive 18, 2 plus positive 9 is positive 11. So 2. Again, we don't have any number in front, so we don't have to divide by anything. That is your answer. Now, number 8's a good one, and I told some of you guys that I thought it was probably going to be, it was probably going to look like a difference of squares, but I think I did this one because I think more of you guys will catch this. Factors of 5 that add up to be 15. Well, the only factors of 5 are 1 and 5. That certainly does not add up to be 15, so this one cannot be factored, so it's prime. Now, I will give you a hint that on the test, there's going to be maybe 1, maybe 2 like this at the most. So don't put this answer more than twice on your test. There are some people that every other question they put prime, and that's not going to happen that often. Again, like I said, it's maybe twice at the most. So we have 2 terms. So, well, 27 in this list. But is it a difference of cubes then? Well, if you look at your cubed, what about 8? It's a difference because it's a this one, the biggest thing is finding your A and B. My A for this one is 3 to the third, so it's 3 and then x, because x to the third is x to the third. 8 is 2 to the third, so my B is 2. Plug this in, so we have our formula is here. Since we started with a minus sign, we're going to do the way I always remember this is you always start with whatever sign they give you. X minus 2, same as the next one is the opposite. So whatever one is the opposite, and the third one is always. Move on these parentheses here because 3x squared is completely different than 9x squared. This is the one you're looking for, so you have to square both of those. So make sure you use parentheses. So this is plus a times b, so x times 2 plus 2. That simplifies. Squared is 9, then x squared. 3x times 2 is 6x. Myself some extra room, but you can always rewind it. See those. You will not have one like this on the test. Obviously, maybe you have extra credit, but normally speaking, you won't have one like this on the test. Now, the reason is because I think it's a little bit too difficult, and I told you that when we did the lesson over this. This one is not a difference of squares. The 3 is not in there. It's not a perfect cube. 25 is not in this list. But if you can take out a greatest common factor. That leaves us x minus 125. Now here's the catch with this one. This one you can still factor. So if this one was on the test, I would probably put factor completely. So you knew more specifically, they had to factor some more. But again, you are not going to have one like this on the test. To finish one, go ahead and do this one. So my A is x, my B is 5. So you end up with x, it's a minus, then x squared x times 5 plus 5 squared. Oh no. Just some room. Okay. Oops. X squared plus 5x plus 25. So if we took it out, it still needs to be no factoring. So 1 plus 12 goes on the top. Factors of 12 out of 2 and you have 1, 12, 2, and 6. Negative yet because those still all multiply to be positive 12. But just like we said in the past, we add up to be positive, but we want negative signs. So put both of them minus. They still to negative 7. They still apply to be positive 12, and that's what you need to double check. I've had people before that change one sign and they think that's good. You need to double check. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 6 minus 3. You're probably tired of hearing me say it, but we do not have to divide those because we don't have anything in front. Let's look at number 12. We have negative 20 on top. 8 factors of negative 20. 20. Negative 2. I put that. Negative 4 and 5. So which ones add up to be positive? 2 and 10, and that one does work out. You don't have to change any signs, but it's always good to double check. Negative 2 times 10 is negative 20. Negative 2 plus 10 is with x minus 2. Broken record, but you would divide both the 10 by the number in front. We just don't have a number in front. And sorry, I maybe squished this on a little bit too much, but I was trying to get it where I didn't have to use a ton of paper on this. So with this one, it's the same one we've done before, where we have 3 times 8 goes on top, so that's 24, and they add up to be 10. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of those add up to be 10? So here's the conundrum with this one, and this is what a lot of people make with. C, what they see is the 2 and the 12, and they think that adds up to be 10. The problem is that would only add up to be 10 if the 2 is negative, but if you change the 2 to be negative, now it doesn't multiply to be positive 24, it should be negative, so that's definitely not right. So that's not the one you're going to use. 4 and 6 is the one you want to use. Again, those both multiply to be 24, and they both add up to be positive 10. So x plus 4 and x plus 6. Now the same thing I've been preaching you for the other ones. Try to mention it, but we need to get that 3, the denominators here. Reduce. 4 over 3. Whoops. 4 over 3 doesn't reduce. 6 over 3 is 2. So whatever doesn't reduce moves into the front. So 3x plus 4 times x plus 2. Same thing with this next one. X, 6 times negative 20 is negative 120. Factors of negative 120 to be 7. So this could be a long one, so get your calculator ready if you need it. 40. And 20, I believe. Works. 120 divided by 7 is a decimal. 120 divided by 8 maybe does work. 8 and 15. 9 shouldn't work. 11 doesn't work, and then we're back to 12. Since we're back to a number we tried, we can stop there. So again, I know a problem like that seems like it takes a little bit of time to set it up, but really it's kind of monotonous, and it's hopefully not super mentally. To be 7, negative 8 is equal to positive 7. From here, we have negative 8, positive 15. Because that's the number on top. Reduce. Both by 3 and 5. Move your number from 3x minus 4 times 2x plus 5. Whew, it's a lot of work on that one. The next, it is a trinomial, so you use your x factoring, but first we don't have an x squared. So the good news is we have to factor out something first from that. You could not only just, you could also take out a 4, I want to say. X squared minus 8 plus 3x. So to see the effect, that should be your answer for this one. And just doing a quick double check. No. Okay. Sorry, baby. This 8. I was thinking 40 divided by 8 or divided by 5. It doesn't matter. It's 10. Okay. Whew, that was close. And the last one, again, number 16. I don't know if you'll have any of these, but it's not a perfect square. 7 is not a perfect square. It's not a perfect cube. So we're going to talk about taking out greatest common factor. So I'll take out a 7. That leaves you x squared minus 5, I believe. But even if you look at that, you can't factor that out anymore. It's not a difference of squares because 5 is not a perfect square. Excuse me. These next two both have 4 terms, so we're going to use factor grouping. Remember, when you start about grouping, if that middle term or the one that's in group, if that starts with a negative, you need to keep that in there. X squared, so 6x plus, you need that. Negative. The negative, just like before, everything that's not inside parentheses. And then we have the 6x plus 1 parentheses. Now, very similar. Put those together. First part between 21 and 84. It is. So I can take out a 7x squared, which leaves me with 3x minus 12. So here's something, I don't think you'll have one that's this complicated with these big of numbers, but I took out a 7x squared, which left me with 3x minus 12. Here's the thing, and if you continue to do this, you'd get most of your credit. You only miss half a point. But I notice I can still take a 3 out of there. So this 21, 4 is 21. So you can actually take out 21x squared, which leaves 1 is 4, so x minus 4. I did not know that. Between the 15 and the 60, I'm going to take out a 5, maybe. See how that works out. So 15, no, can't be. Oh, it's 15. Sorry. Take out a 15. And that leaves me x minus 4. Now, one reason, once I got on the right track, one reason I knew it wasn't 5 is because that gave me 3x something, but that does not match this parenthesis, and so I knew it's got to be different. So that's one thing I did to check my work, or that I caught myself. Now we have 21x squared plus 15 times x minus 4. Majority of you guys, that's it. Answer, you can quit there. This is going to be your correct answer. Again, I'm not going to have one on the test that's this complicated. I didn't know this one was on here. I will change it for next year for what it's worth. Hopefully that doesn't mean anything to any of you guys. But this is the correct answer. This is how you should leave it. Just in case you notice this and you're shouting at the screen, you can actually keep something out of this. So between the 21 and the 15, you can actually factor out a 3. I'm not going to touch that. Also, just FYI, since we noticed that, I am guessing from the very beginning we could have factored out some sort of greatest common factor. But again, I don't want to make it more complicated than it has to be. You will not have one that's like that. You won't have one where you take out a greatest common factor, then do factor by grouping, or do factor by grouping and then keep factoring. I guess ultimately you will not have a factor completely problem that's like this with factor by grouping. So if you did this one and you ended up with this as your answer, that is good enough. And again, these numbers are bigger than what you'll have on your test. I'm going to make sure of it. I'm going to check right after this. Moving on, number 19 and 20. These are both difference in squares. And again, you can tell because 121 is on your perfect square list. And 100 are both also on your perfect square list. So these are both perfect squares. And you're subtracting. A for this one, X, your B for this one. If you don't know, you can use your table. 121, that is 11 squared. And again, you will have the formula for this, but I think most of you guys probably don't need it. And for the next one, if you don't know, is 7, and then don't forget the X. Squared is just an X. And so you get 7x minus 10. Kind of a nice breath of fresh air after this monstrosity nightmare that showed up. Sums and differences in one way, and the way you're going to, they're all binomials, 2 terms. But again, all these numbers are on the list. So 27, let's erase this to make it kind of a clean slate. 27 is up here. 127. 8 and 1. So all those are perfect cubes. That's how you on your list of perfect cubes. You don't actually need to the test, but this only goes up to 15. You can obviously keep this going. Your A, B, 27, B is 10 to the your formula. You end up with 3x plus 10. We start with plus because that starts with plus. Minus 3x times 10 plus 10 squared. I would definitely recommend you very much quite literally this term. X plus 10. If it wasn't for that first term, most of you guys would get it right with parentheses, but it's got to be 9x squared, not 9. 3 times 10 is 30x, and 10 squared is 100. So that's number 21. Same thing, and I will erase that in a bit here. Actually, I might as well erase it. You guys can always rewind. 12 is 8 to the third. We just said it was 3 to the third. B, so again, we have 8x minus 3. Now, the reason it's minus is because that's how it starts up here. Second part of 8x squared. Now it's a and then and then 3 squared. Divide this out, 8x minus 3 times 64x squared plus 24x. Again, going and looking at my A 1. A lot of people get confused by that. 1 to the third is 1. And it's minus again, so we have 2x minus 1. 2x squared plus 2x times 1 plus 1 squared. I should use parentheses, but I ran out of room. That is 2x minus 1 times 4x squared plus 2x plus 1 is your answer for that one. All of them today, or all of them in this chapter, you can do this. But again, just a really quick way to double check. If you took 2x times 4x squared, that should give you the 83, or sorry, 8 times x to the third. Same thing over here. 8x 6x squared should give you that 512x to the third. So that's again, if you get that right, that doesn't mean you definitely got the right answer. But if you get it wrong, then you definitely did something wrong. So it's a good way just to do a quick double check. It's not 100% accurate, but it does help to catch if you made a mistake. I think that's it. Cool. So if you have any questions, let me know. Again, just an FYI, just to make sure you hear me say it again. Number 10 is not going to be on the test, not one like that. There will be obviously sums and differences of cubes, and there will also be greatest common factors, just not in the same problem. And also the same thing with that problem we just did, number 18. There will not be greatest common factor and factor by grouping all in one problem. So don't fret over those. But if you have any questions, make sure you let me know.